So we're on page 16 in your unit packet. I want to do one because it covers so much of what we've done with the area and volume questions. So page 16, I'm looking at question 1. I've already got it set up. So if you want to, go ahead and hit pause. Put these equations on your calculator so that you can get your graph. Okay. I've kind of done that already, so I cheated a little bit. I drew my graphs ahead of time. So what we are doing in this question, we are using the exact same bounded region for every question for A, B, C, D, E, F. I'm just doing different things to the region. So first of all, you have to get your graph. Y equals x to the 2/3. That's this curve here. It kind of looks like, I don't know, it kind of goes through the origin and bounces, kind of doing something like that. X equals 0. That is your y-axis. That is your y-axis right there. And then I have y equals negative x plus 2. That's this diagonal line. If you graph it, then you're going to see this bounded region right here. It tells you it's in the first quadrant, and I want to be bounded by my line, that x to the 2/3, and then my y-axis. So this is the region I'm dealing with. I don't know if you can see that. I kind of shaded this in. I have the point of intersection right here is 1, 1. And then this point up here, that's a point 0.02. Okay, so that's what I'm starting with. So for part A, it says find the area of the bounded region. Okay, so if I want to find the area, then I just have to integrate top minus bottom or right minus left. I can do either. If I draw, bottom is kind of my default, so that's what I'm always going to try to do first. If I draw a vertical line anywhere in this region, no matter where I draw it, the line will always be on top of the curve. So that means that I can integrate using top minus bottom. So for the area, I want to integrate the top minus bottom. Well, the top is the line, which is negative x plus 2, minus the bottom equation is the curve, x to the 2/3 dx. And of course, I'm doing this from 0 to 1. I'm doing this from 0 to 1. That's all along the x-axis. And that's all you have to do. You can put that on the calculator, but we're going to focus on the setups because I think you guys are fine with the calculator at this point. So that's just finding the area. You integrate top minus bottom or right minus left, but we did top minus bottom. Okay, question B. Notice I have the exact same bounded region here. So I already sketched it. Again, I cheated. It's the same exact bounded region. What I am doing is I'm revolving this around the x-axis. So I'm revolving this around the x-axis. So I have my bounded region and I have it shaded in. If I revolve it around the x-axis, I'm going to try to draw something here. I don't know if you can kind of picture what this looks like. I almost look at this as like a sideways, like a volcano. The sides are slanted, but then you have this curved out hollow part on the inside. And again, the big thing that you want to pay attention to is that this is not a solid shape. There's definitely something missing from the inside here, which means we have to draw 2 radii from the axis of revolution to the outer axis of revolution to the inner bounded region. So that's what I have right there. And again, if you recall, volume equals the integral of area. Well, in this case, it's pi r squared because I'm revolving, so it's always circles. So the pi I'm going to put on the outside, the integral, I need to do the big radius minus the little radius, and of course they're squared. So pi big R squared, that's the area of the big circle, and I'm subtracting pi little r squared. That means I'm subtracting this inner region right here that's missing. So now, based on what I drew, to find the radius, I'm going to do top minus bottom. And of course, you're always going to do the same thing for both radii, for the big and the little. So now I just have to fill in all my information. The volume is going to be pi, the integral, all x's. My big radius, if I look at the big radius, the equation on top is the line, negative x plus 2 minus, I'm revolving around the x-axis, so that's 0 squared. So that's the pi big radius squared minus, now I have to do the smaller radius, top minus bottom squared dx. And that's your setup for that. Okay? We're getting there. A and B are done. Let's go to C. Same bounded region again. What I'm doing now is revolving it around the y-axis. So I'm going to revolve this bounded region around the y-axis. So it's going to look something like this. Oh, that's terrible, but whatever, you get the idea. And again, it's rounded. I don't really know what this shape would be, but it's something. Again, the important part is that it's solid. This is a solid figure. So now I want to draw a radius from the axis of revolution to the bounded region. Well, if I draw that up, I hit the line. But what if I draw it down here from the axis of revolution to the bounded region? Then I'm hitting the curve. So that tells me when I draw that line in, I am obviously doing right minus left, but the right hand side changes midway through this shape. So what I'm doing, I have to cut this shape in half, the volume of the bottom part and then the top part. Remember, this point of intersection right here is 1, 1. This point up here is 0, 2. That's from when we first graphed this. Now, because I'm doing right minus left, all of my equations have to be written in terms of y. So we have to the 2/3, which means x is equal to y to the 3/2. X equals 0. That's my y-axis, so that's not a big deal. I don't have to change that around at all. But I also have y equals negative x plus 2, which means x is equal to 2 minus y. So because I'm going right minus left, now I have equations that I can use, because now I have equations in terms of y. So that's what I'm going to need here. So to find the volume, I need to integrate the area of a circle. I'm going to do this twice though. I have to do the bottom half and then the top half. Okay? So to find the bottom, pi integral from 0 to 1. Those are from my y coordinates. This right here is the point 0, 0. I'm using the y coordinate and the y coordinate. Okay? And then I have to do right minus left. The right hand side is the curve y to the 3/2 minus 0, because that's my y-axis. So pi r squared. Pi r squared, that will get me the volume of the bottom half of this, plus. Now I have another integral that I'm going from 1 to 2. Again, I'm using my y coordinates. And now when I do, oh, I need my pi. I can put that out in front or inside. The radius for the top half of this is going to be right minus left. Now I need the line squared dy. That one's a little tricky. It's a solid shape, so I only need pi r squared, but I have to do it once for the bottom half and then once for the top half because I have different equations that are on the right hand side. Okay, D. Same bounded region. I'm now revolving it around the line 1. Revolve it. I'm going to have something like this. I don't know, something like that. Very similar to the volcano-y shape that I kind of talked about in part B. If I look at this, I want to draw the radii. And again, the important part is knowing that, okay, there's something missing from the inside. From the axis of revolution revolution to the inner bounded region. So that's what I'm looking at right there. So to find the volume, pi integral big R squared minus little r squared. So I need to find pi r squared, that's the big circle, that would give me the entire volume, and I'm subtracting pi little r squared, that's a little radius. I'm subtracting this triangular piece, this like cone shape that's been removed from the center. How am I going to find the radii? I can do top minus bottom. So both of these are going to be top minus bottom. So I set up my formula for volume. I'm going to do the integral. Oops, I'm going to put pi out front. Integral 0 to 1, back to my x's because I'm doing top minus bottom. Now for the big radius, the equation on top is 2 minus so that's pi big R squared minus, now I need my little radius. The top is 2 minus the equation of the line. Negative x plus 2 squared dx. So that one's not terrible. Watch out over here. You can distribute that if you want, or just put the equation of the line in parentheses. Either way, it's the same. Okay? Alrighty. We're getting there. E. Put around x equals 1. Okay. This right here is 1. So I'm revolving it around this line. So I don't know if I can draw this. It's something like this. I don't even know, like it's, I'm gonna mess up the picture, so I'm just gonna leave it alone. It's almost so now, if I draw from the axis of revolution to the outer bounded region, and then the axis of revolution to the inner bounded region. Now here's where I have to be careful, because what if I had drawn those on the top part of my picture? Axis of revolution to the outer bounded region, axis of revolution to the inner bounded region. Notice that when I do this, if I depending on where I draw that my radii, it changes what equation I hit, which again tells me I have to split this in half and do it as 2 separate integrals. So now I have to do the bottom and the top. So it's very similar to that other question we did. What was it, part C? Only now it's missing a piece, it's hollow. So I have a little more work to do. So I'm going to focus on the bottom here. Okay, so the volume equals pi, the integral. So I'm just looking at this bottom piece right here. This is where I'm focusing. I need the big radius, and I need to do right minus left. So right minus left squared minus, now I need to do my little radius. Right minus left. Right minus, and then the left hand side is the curve, which we figured out before, y to the 3/2 squared dy, and of course I need limits. I'm going from 0 to 1 on the y-axis. I'm going up the y-axis from 0 to 1. That's what I have there. So that's going to give me the volume of this piece down here. So I just found the volume of that piece right there. I need to add to that the volume of the top piece. Okay, so now I have the integral from 1 to 2. Put my pi on the outside. So now I have to do big radius. My big radius, right minus left, minus my little radius, which is right minus, and then the left hand side is that line, 2 minus y squared dy. That right there I would consider worst case scenario. Not only do you have a big R minus a little r because we have something missing from the inside, but I also have to divide it into two separate parts because of the way the graph is drawn. It gets pretty messy, but again, on the AP test, a lot of times they just ask you to set it up. So you would be done right there. Obviously, if I were doing this on my calculator, I would put the first interval on my calculator, get an answer, then the second one, get an answer. I might even do some work. I might even like simplify some of these things in here, distribute, simplify where I can. Okay. Whew, one more. Okay. And I just, hopefully you could see that whole previous question because I just realized it might not be totally centered on the screen, but I'm sure you guys will figure it out. So for the last one, here's my bounded region, and now I'm revolving around y equals -1. So here's -1. If I sketch that in, I'd be revolving around that. So let's see here, I'd be doing something like this. Again, it's kind of like that volcano shape I've been mentioning before, only you can go all the way through. Maybe it would be more like a, what is that called? Is it a bundt cake that has like the hollow on the, whatever it is. It's definitely missing pieces on the inside. So what I want to look at, I'm going to draw from the axis of revolution to the outer bounded region, and then from the axis of revolution to the inner bounded region. That's what I'm looking at right there. Now you'll notice no matter where I draw those in this picture, the outer is always going to be the line and the inner would always be the curve. So this is beautiful. I don't need to split this up. I'm back to top minus bottom, which is even better. -x plus 2 minus the equation on the bottom is -1 squared. So that's pi r squared, that's my big radius, minus, for the little radius, top minus bottom squared dx. Limits are 0 to 1. Hopefully that makes a little scenarios as to what you might have to do in terms of revolution. So hopefully we're okay with these, and again, it's the setup that's important. Of course there's simplifying you can do in here, but again, you don't need to waste your time doing that if you don't want to. The AP test does not require you to simplify everything. They just want you to set it up accurately. And remember, if they say set it up, you have to have your dx's and dy's at the end. That is part of your setup, okay? Alrighty.